Why do planes take long paths before landing? A passenger jet is only a few miles from the airport now, low enough that people in backyards can hear the engines rolling across the rooftops, close enough that the runway almost feels like it should be right there, waiting beneath the wing. Then, just when the airplane seems ready to head straight in, it turns away. It drifts into a wide arc over neighborhoods, fields, highways, rivers, sometimes even out over open water. Inside the cabin, passengers lean toward the window and wonder why the plane is taking the long way around. But landing is not a simple straight line to the ground. It is a carefully shaped descent through invisible roads in the sky. In the earliest days of aviation, landing was much simpler to imagine and much more dangerous to actually do. A pilot aimed for an open field, studied the wind by watching smoke, trees, flags, or the rippled surface of a pond, and then tried to ease a fragile aircraft onto grass, dirt, or whatever flat ground was available. There were no packed arrival corridors, no glowing screens full of navigation points, no controllers guiding streams of airplanes from miles away. The airplane was slow, it was light. Most of the time it was alone in the sky. Even then, pilots learned a lesson that never went away. The shortest path was not always the safest one. Airplanes cannot simply drop out of the sky like elevators coming down a shaft. They need air moving over the wings. They need the right speed. They need enough space to turn, slow, and settle. Whenever possible, they also need to land into the wind because that lowers the speed across the ground and gives the pilot more control at the very moment the wheels are about to touch. So even in the age of open fields, leather helmets, and fabric-covered wings, landing often meant circling, judging, turning, and lining up with care. As flying became more common, rough fields slowly gave way to proper airports. Runways grew longer, harder, and more organized. More airplanes began arriving from different directions, at different speeds, with different needs. The space above an airport started to feel less like empty countryside and more like a busy intersection, except the roads were invisible and every vehicle was moving in 3 dimensions. The long path before landing did not begin as a delay. It began as a way to bring order into a sky that was getting crowded. Early pilots still depended heavily on what their eyes could find below. A runway, a coastline, a church tower, a river bend, a row of lights at night, shining through the dark like a thin invitation home. Approaching an airport meant building a mental picture from the landscape underneath. But weather could erase that picture quickly, fog could hide the runway, rain could smear the world into grey. Low clouds could cover the airport until the aircraft was already uncomfortably close. To make landing safer, aviation gradually built guides that pilots could follow even when the ground disappeared. Radio signals helped aircraft find their way when familiar landmarks were gone. Runway lights marked the edges of the pavement and helped shape the approach at night or in poor visibility. Controllers began organizing arrivals from the ground, using radios to separate aircraft that pilots could no longer reliably see with their own eyes. Little by little, the sky around airports became structured, not with pavement and signs, but with instructions, signals, and shared rules. The familiar landing pattern became part of that structure. An aircraft might fly alongside the runway, pass the end of it, turn across, and then turn again toward final approach. To someone watching from the cabin, that shape can feel like a needless detour. But for the crew, it creates time. Time to slow down. Time to lower the landing gear. Time to extend the flaps. Time to check the wind, watch for traffic, and make sure the airplane is stable before the runway fills the windshield. What looks like a loop is really a controlled setup. That setup matters because a landing aircraft is constantly changing. It is losing altitude, reducing speed, changing the shape of its wings, adjusting power, and moving from the smooth speed of cruise flight into one of the most exact moments of the entire trip. The airplane that crossed the country at high altitude has to become something different near the ground. Slower, more controlled, more deliberate. The long path gives it room to make that transformation without rushing. Then came the era that made long approaches truly necessary. Bigger airplanes, faster airplanes, and skies filled with commercial traffic. As air travel expanded, airports were no longer handling a few scattered arrivals with plenty of empty space between them. They were receiving steady streams of aircraft, one behind another, arriving from different cities, different altitudes, and different corners of the map. Jets changed the rhythm completely. They crossed long distances quickly, arrived near airports from high altitude and needed more room to descend and slow down. A small early airplane could lose speed and height in a much shorter space. A heavy jetliner could not be handled that way. It carried momentum. It needed planning. It needed distance. It needed a descent that began long before passengers could see the runway out the window. Radar gave controllers a much clearer picture of the sky, and that changed the landing process in a major way. Aircraft could now be arranged like moving pieces on an invisible board. One plane might be told to turn left. Another might be cleared to descend. Another might be asked to reduce speed. Another might be lined up behind the aircraft ahead. From a passenger seat, it may look like the plane is making a random loop over the city. In reality, that loop is often a carefully measured gap being created in real time. Sometimes the long path is simply a queue, but not the kind people are used to seeing on the ground. There is no rope line, no painted arrow, no row of cars waiting bumper to bumper. The line is stretched across the sky. A plane may fly extra miles because another aircraft is landing ahead of it, because a departing aircraft needs space to climb out, because another runway is being used nearby, or because weather has forced arrivals into fewer safe corridors. The airplane is still moving, still descending, still being placed into the right spot. Weather can turn that placement into something even more complex. Thunderstorms are not just dark clouds sitting in the distance. They are moving walls of turbulence, lightning, hail, powerful updrafts, and dangerous downdrafts. Aircraft do not casually slice through them on final approach just to save a few minutes. They bend around them. They wait for a safer opening. They may follow a route that looks strange or inefficient on a flight map, but that route is avoiding the invisible violence inside the cloud. Modern landing paths are shaped by a mixture of physics, traffic, geography, noise, and safety. Airports are not floating in empty space. They are surrounded by real places. Neighborhoods, mountains, rivers, military zones, tall buildings, restricted airspace, and sometimes other airports only a short distance away. A plane cannot always approach from the direction that looks most direct on a map. It must use the runway that fits the wind, the traffic pattern, the airspace, and the conditions of that moment. That is why many aircraft follow published arrival routes before landing. These routes guide planes from the high-altitude world of cruising down toward the airport in organized steps. Instead of every pilot choosing a personal path to the runway, arrivals are shaped like funnels. Far from the airport, the routes may spread wide across the sky. Closer in, they begin to narrow. Altitudes are assigned, speeds are managed, turns are planned. By the time the aircraft reaches the airport area, it is not wandering. It is being guided into a larger pattern. The long curving path can also help manage noise over the ground. Airports sit beside cities, suburbs, industrial areas, coastlines, and highways filled with everyday life. People are sleeping, working, cooking dinner, walking dogs, putting children to bed. In many places, arrival routes are designed to keep aircraft over water, open land, industrial zones, or less crowded areas when possible. The path may be longer because the airport is not only managing aircraft, it is also managing the world underneath them. Inside the cockpit, the final approach has one main goal: stability. By the time the aircraft is close to landing, it should be lined up with the runway, descending at a controlled rate, flying at the correct speed, with the landing gear down and the flaps set. The crew wants the picture to look calm and predictable. If that stable picture does not come together in time, the safest decision may be to stop the landing, climb away, and try again. That is why pilots do not want rushed landings. A steep dive toward the runway might look faster from the outside, but it is not how airliners are meant to arrive. A large passenger jet needs time to slow down, configure, and settle into the proper approach. It needs time for the crew to verify that everything is where it should be. The long path is not wasted distance. It is a safety buffer drawn across the sky. One of the stranger parts of modern aviation is that aircraft can fly with incredible precision, yet they still cannot escape the messy reality of the atmosphere and the airport around them. A flight computer can follow a route smoothly, almost perfectly, but the wind may be stronger than expected. A controller may need more spacing. A runway may change. A bird strike, a medical emergency, a disabled aircraft, or a sudden storm cell can reshape the entire arrival flow in minutes. The plan is precise, but the sky is alive. So when a plane seems to wander before landing, it is not lost, confused, or wasting time without reason. It is entering a choreography built from wind, traffic, instruments, and decades of aviation lessons. The runway may be visible through the window, close enough to make passengers wonder why the airplane is not going straight there.